In this video, I'm going to show you the basic aspects of the syntax of FatScript. Let's go! On the last video, I showed you how to install Fry on your machine, and on this video, we are going to see how to use the basics of the Fry interpreter and of FatScript language. So the first thing you can check to see if everything is fine and installed, you can just run fry -v. It should give you the version of the Fry interpreter that is installed on your machine. And also you can do fry -h to give you the command line options for the Fry interpreter. So if you just want to run the REPL mode, the interactive mode, you can just type fry and it will start in the interactive mode. In this mode, for example, if you do 4 + 4 and put a semicolon, it will output you the result. But hang on for a little while, we're gonna come back to the interpreter. You can also use Fry interpreter to interpret scripts, to interpret code that is stored on a file, of course. So with Fry, we ship a lot of samples, like on the folder sample. So you can see that there's, for example, the Fahrenheit example, which is far. So let me show you the code. Nano sample far. So here on this script, you can see a few features of the language. For example, here with this arrow to the left, we are importing the libraries console and math, and the underscore indicates that we are importing it to the global scope, to the root level of your program. Then we define a lower limit of temperature table which we want to print, the upper limit, and the step we're gonna increment the temperature to print out each of them. So we declare a variable Fahrenheit which starts at the lowest value, and then until it gets to the upper, we are gonna use an at which is gonna iterate over it. We calculate the Celsius value from it using some math, and then we use the log function which was imported from the console to print Fahrenheit, then a tab in the middle, and then the value of Celsius. Okay, and then we increment the step, and when this executes, we can execute code with Fry interpreter by doing like fry sample and then Fahrenheit, and yeah, it's gonna print out the results of that execution, which is obviously what we expected here. So now let's go back to the Fry interpreter itself and walk through a few steps of what we can do with Fry. Okay, so one thing that is also suggested here when you start Fry is that you can print the help. So help is the only command you don't need to put a semicolon at the end. You can, but you don't need to. And if you use this command, it will import a few libraries for it to be able to run, and it will start printing help information on the screen, so you can get more out of FatScript directly in the interpreter. So if you type help all, it will give you all the commands you can run with help. So we are going to start with the help formatting here. So if we go here, cool. So what you know about FatScript formatting, the basics is white space is ignored, but very encouraged, so you can have better readability of the code you're writing. New line, it ends an expression unless you have a line that ends with an operator, or the next one starts with a non-unary operator, which is like, for example, exclamation mark, which will turn a Boolean value into its opposite, like false is going to be true, true is going to be false. Or if you use parentheses, then you can put new lines in the middle and it will interpret everything together as a single expression. Otherwise, you can also use commas and semicolon to put more than one command in the same line. However, note that the comma is kept the same when you use the formatting function. But if you use Fry to format your source and you are using semicolon, it's gonna replace it by new lines. So that's a slight difference from one to the other. And regarding comments, it's similar to other languages. We use the hash symbol, the pound symbol, in any place in the line, at the beginning or in the middle. And after that symbol, anything you write is considered comment. It's not gonna be interpreted until a new line is found. So now let's see the help about imports. For imports, we already seen a little bit of this on that example for the Fahrenheit one, but you can import to reference the library you're trying to import using an arrow to the left. So for example, if you want to write the most simple program everybody writes, which is the Hello World program, we're gonna import to console, to this reference, the library fat console. Okay, so now this means that I have, if I type console, you can see that we have here a function which is log. It will print out to the console with a break line, and there is also print, which prints out without a line break. You can also check what's in the library using help console, and it will print in a nicer way what are the functions in this library. Here you can see, for example, the log function we're gonna use. So if I say log hello world, actually we did import the library into a reference, so we need to prefix the function call with the library name. So let's put here console dot log hello world. Now this is gonna work, right? As we expected, it printed out to the console the text that we provided. Cool, so that's the first program that you can create. Now let's look at the entries, because a big part of FatScript is entries. So you can just directly create entries in FatScript by declaring them with the equal sign, as long as the entry is using a lowercase letter as the first letter. That's very important, because in FatScript types start with uppercase and entries or variables start with lowercase. Now if I create a variable here like a is 5, that's gonna create a is 5, right? But there is one thing you should note, is that this is actually not a variable, because you didn't inform FatScript that you want to change the value. So it considers it as a constant from now on. Until you end your program, a can never change again. That's considered immutable. So that's one of the characteristics of how FatScript works. So if you try to say now a is 8, it's going to give you an error, because you're trying to reassign a value to an immutable value. Now you can tell FatScript that you don't want something to be immutable by providing the tilde operator at the beginning. So let's say b equals 5, and then I say b equals 8, and it's gonna say all right, because b now was declared as a variable. It's a mutable entry, right? You can have Boolean entries, numeric entries, text entries. You can also have some other types. For example, you can have a list. Like, let's get a list here. It looks pretty much like you would do it in JSON. So list equals, I'm gonna use 1, 2, 3. That's my list. Okay, cool. One thing I can do with lists is I can select from the list using an index. So if I select 0, I'm gonna get the number 1, as we would expect. I can select using ... 1, which would select from the beginning of the list until the position one inclusive. This would bring us 1 and 2. I can also do similar things like that, for example, with text. So let me create here a text, which is my name, Antonio. And the same kind of feature will work. For example, text 3 is going to select the character at the position 3 from a 0 index based string. So in this case, it's going to be O, which is at the position 3 if you count 0, 1, 2, 3, so it's O. And then also you can count backwards using the minus sign. So for example, -1 is going to get the O at the end, -2 is going to get the I at the very end. And well, that's basically how you can access indexed values like lists and texts. Now, let's get a little bit more about the types itself, the type system. So in the type system, we have some basic types. Again, remembering types are declared using capital letter at the beginning. And we have a few types, which are the basic types in FatScript: any, void, boolean, number, text, method, list, scope, and error. And any is like a virtual type. It's really just to be used to inform that you accept anything. So if I say a equals any, yeah, it's true. And actually anything would be any. But if I say a equals void, which is the opposite, like nothing, it will say, no, that's not true. And there is also other ways of checking against types, like true equals boolean. This is gonna be actually fun because it's responding with a boolean. But false is also a boolean, you're gonna see, so that's expected. And yeah, true, because it's a true or false kind of question. Now, you can also use methods as any other variable. For example, I'm going to create a method here which takes in a n, which is a number, and then it returns me a number, and this arrow to the right is the sign used to declare a function. So I'm going to take this n and I'm going to multiply it by 2. So my simple function is just going to double anything that I pass in if it's a number, else it will give me an error. So if I do m of 5 as expected, I'm going to get the number 10. If I do m of 15, it's going to give me 30, and so on. I can also assign a function to any entry. It's just a value like any other value, which is a very interesting feature because then you can pass methods around. So you can say n equals m, and for example n of 8, it's 16 as we would expect because the method has been assigned also to n. Now let's see a little bit about flow control. So help me about flow control. So flow control is the basic way you can make your program make decisions. The most basic one is the double question mark, which stands for defaults or nullish coalescing operator or operations, which basically is going to check if the first thing exists, it returns that thing, else it returns the other thing. So for example, a we have created before, which is 5. If we took a and 10, it's gonna choose A because A exists. And if we do the same thing with C, which we have not created before, it's not gonna find C, so it's gonna say, oh, I don't have any C, but I'm gonna give you 10 because that's the default value you have provided. Another way of doing this is using an if, which is declared using a question mark. It could be the same logic, but a bit more verbose. Let's say, for example, A is null, then if it's null, then return 10, and then if not, you return A or return 5 or whatever. I mean, and the other question would be, if I put like C here, Now we don't have a value, so it's going to return 10. But we could also do something a little bit more interesting with if-elses. So if I use the column, I can actually choose to do one thing or do another thing, and not just checking if something exists or not. So if a is less than 4, let's increase it a little bit. So let's add 1. And if not, we're gonna decrease it a little bit. So a minus 1, right? Now let's make this a function so we can play a little bit with it. And let's call it fn equals a that passes this into the function, and it's gonna execute this as we had seen before. So with this function, we now can do fn of 3, and what we expect is this is less than 4, so it's gonna add 1, so it's gonna return 4 as we expected. And if we do fn of 5, 5 is more than 4, and it's gonna decrement 1 of it, so it's also gonna return 4. And if we do it with other values like fn of 8, of course, it's also gonna sum 1, so subtract 1, so it's gonna return 7. And if we do it with 2, it's gonna also add 1, so 3. That's kind of what we were expecting here. Now, finally, we get another kind of flow control, which is called cases. So the cases is a way to chain many conditions in a row, and it can be very useful, especially when you have a function block. You can put it at the end of your function to select what you want to return from the function. So for example, I'm going to create a new function, a function number 2. It's going to take an n also as a value of input. We're not doing all that type checking here just to get it straight out, but you could add it, and it would be actually very useful to make your function and your code more robust. That's not the case here for this example. So if n is less than 3, I'm gonna return here that this is very little. So just some information of classification we're doing here, a little. And if n is more than, no, actually less than 6, so it's between 3 and 5, actually inclusive or less than 6, then it's gonna say, okay, sum. And otherwise, we just want it to return, otherwise, you don't need to say anything, you just put underscore and you say what you want, just return many, right? So this pretty much is our function, function 2. So if we call fn2 of 2, we expect it to say this is little, right? And it says it's little. So now if we pass it in a value like 4, it's gonna say this is sum, and if we pass a value like, I don't know, 10, it's gonna say this is many. And as we expected it, it behaved that way. So now for the final part, we have loops. In FatScript, you can create loops using either a condition and then using the add operation for then the loop body, or you can use a mapper function, right? So there are two ways basically you can do it. So if you have a condition, it's gonna loop through the body and execute something in the body, as we've seen also in the Fahrenheit example. And for the other options, which is ranges or collections, you're gonna use a mapper. So I'm gonna go directly to the example for scopes, which we haven't talked much about so far. And we're gonna create a scope. So scope is also JSON-like syntax. One thing to note is that the scope will always store the values it has from the keys it's storing in an alphabetical order. And if we loop through this scope, so I'm gonna put my scope at, it's gonna give me the key as the input. So if I just print it out, if you just don't do anything, if that's the output of the function, so basically it's gonna return me a list containing my keys. Now I could also use that key to access the value in the scope. So I can do my scope dot key, oh sorry, actually key like this, because key is a string. So it's gonna give me the values. Now I can do something more interesting than that. I can, because this is a function, I can map it using, for example, an operation. So we are gonna sum 4 to each of the values. Now it's gonna return me a list with those values updated with 4. I can also use the mapping feature to filter out values that I'm interested on or I'm not interested on. For example, I can say if this value is less than 2, I'm interested on it, so please return the value. So I'm gonna do this, I'm gonna just get the value again. So scope key. So what it is doing is it's checking the value of what is in that key, and if that value is less than 2, it's gonna return that value. If not, it's not gonna return that, that value. So it's effectively going to filter them out. And there we have it. It just brought us the numbers 1 and 2. So yeah, basically I think we had an overview here of the basic features in FatScript, and I hope you already are able to start playing around with the language, reading about on the documentation on the official webpage fatscript.org. And if you have any doubts, please put comments on this video. And I'm planning to create new videos where I'm gonna show you how to use to build little programs, and so you can learn the language by building together, which I think is the best way to actually learn the language. This video was mostly intended for programmers, for people who already know how to program, and so they can start right away to use the FatScript language. So I hope you enjoyed it, and I see you on the next video.